It is the most expected heavenly demise within recent memory when the Goliath star, Betelgeuse, changes into a hazardous cosmic explosion. It will sparkle overhead as brilliantly as the full moon and can even be found in sunlight, sadly. Anyway, we don't have the foggiest idea when precisely this fierce destruction will happen. Later, the heavenly giant was nearly articulated dead after some baffling changes and brilliance. It ought to eventually recuperate well, as of recently, since now Betelgeuse is once more standing out with baffling presentations of light. Another review presumes that the shoulder star of Orion could detonate significantly sooner than anticipated. In 2019 and 2020, the energy it was endless to encompass Betelgeuse. The Goliath star did for sure stand out as truly newsworthy with a radical loss of brilliance, which many experts deciphered as a harbinger of the coming cosmic explosion. There is no doubt that the blast of the monstrous divine body will be a staggering exhibition. After all, the red very Goliath, which is just 650 light-years away, is multiple times the measurement of the sun and right now sparkles multiple times more brilliant than our wellspring of warmth and life in imperceptible light. Therefore, Betelgeuse is quite possibly one of the most brilliant stars in the night sky, which is the reason the development that started in October 2019 appeared to be all the more confounding. The star's radiance is ordinarily assessed to be somewhere in the range of 0.3 and 0.4 in magnitude. To put this into context, the unit magnitude, mag, for short shows the obvious splendor of a star without taking into account the distance of the heavenly body. The more modest the mag value of the star, the more brilliant it appears to us in the sky. When insect juice darkened, the scientists kept a drop in splendor down to 1.1289 mag, while the temperature of the heavenly monster dropped by a decent 100 degrees Celsius at the same time. In detail, the drop in radiance was so critical that it might actually be seen with the unaided eye, because of which Betelgeuse slipped to 21st place on the daily star chart. But how could it be that space experts associate such a scene with an inevitable cosmic explosion? Well, from one viewpoint, there is the fact that the so-called Orion shoulder star has reached the last stage in its development as a red very Goliath, which will unavoidably end in a strong blast. On the other hand, there is the way that this can be declared by solid development, combined with a decline in brilliance. But this is exactly where it gets tricky, because the galactic truth also includes the fact that, so far, there have basically been no exact observations of supernovae prior to their blast. Considering this, we also don't know whether the darkening happens quite a while before the cosmic explosion or only a couple of hours prior. What we cannot deny is that insect juice shouldn't vanish from the grand scene around that time, since we would unavoidably have seen it. According to the specialists, Betelgeuse will sparkle as brilliantly as the full moon for quite a long time. The perishing monster would be so brilliant that it would be nearly difficult to see different stars in its area. Since it would be the most splendid cosmic explosion in the history of observation and the one closest to Earth, it might even be seen in daylight. The greatest drop in brilliance over the most recent 2 years presents new bewilderments, but if the darkening a long time back was not connected to a final blast, what was it caused by? Well, recent observations with the Hubble Space Telescope revealed that a colossal plasma emission made an immense residue cloud that obscured the star by just about 2/3. And despite the fact that Betelgeuse, as a heavenly oldie, consistently launches a lot of heavenly material anyway, this event was something different. A mix of strong convection and expansion likely caused the plasma emission to be a few times more powerful than expected, resulting in a loss of mass 30 million times greater than that of the Sun. Betelgeuse was to get back to its unique glow, but it actually had a couple of brilliance puzzles coming up for us in the period that followed. Exhaustively, the advancement in 2023 was turned around, and the star shone fundamentally more brightly than normal from then on. Yet, consistent with the witticism, where there is light, there is also shadow, the heavenly body lost an intense measure of glow again a couple of months prior. Although the splendor didn't change quite as definitely as in 2019 or 2020, the scientists still recorded the least glow over the most recent 2 years. Once more, perspective on this, the inquiry arises with regards to whether this advancement could be connected with a fast-approaching cosmic explosion. But then, the response this time is, we don't have the foggiest idea. No expert can currently say with absolute sureness whether the monster star will detonate tomorrow or in a million years. Most importantly, it's hypothetically even conceivable that Betelgeuse has since long made its bursting way out, and that the illumination of the last heavenly demonstration has basically not yet contacted us. What's more, a modern-day miracle, a study from 2023, in reality, reaches the conclusion that Betelgeuse might detonate a whole lot sooner than previously suspected. In the run-up to this, a research group from Japan's Tohoku University in Sendai had looked at the throb of the star and, in doing so, uncovered a series of surprising conditions that demonstrate that Betelgeuse is much older than previously thought, as the external layers of Orion's shoulder star beat. This results in relatively normal brilliance variations, the most noticeable of which last 2,200 and 420 days, respectively. Up to this point, astronomers had interpreted the shorter span as the star's pulse, which suggests that we are dealing with a younger heavenly body. But imagine a scenario where the multi-day time span actually addresses the real heavenly beat. Well, that would mean, most importantly, that Betelgeuse is significantly greater than generally expected. Expressed in numbers, the 800-fold solar radius would subsequently transform into a measurement multiple times bigger than that of our Sun. This situation would also imply that Betelgeuse is also unique in its life cycle and that its cosmic explosion is inevitably moving toward. Will Betelgeuse soon detonate? The way that stars change the night sky into a perpetual ocean of brilliant points is due to the displays that happen in their interiors. Stars shine first because they combine hydrogen into helium at their core, and when the hydrogen supply in the center is depleted, helium is used to make carbon, which is ignited with increasing age to form other heavier components. The Japanese study creators use computer simulations to show how the blazingly brilliant divine bodies evolve from their birth to the final stages of their lives, and at what stage they start to throb. In doing so, they brought an amazing truth to light. In fact, all the recorded heartbeats from Betelgeuse can be assigned to a much later stage than previously expected, the carbon-consuming stage. The study states that a few dozen years after the carbon in the center is depleted, a core breakdown is anticipated, leading to a cosmic explosion blast. Tragically, it was not possible to limit the expected date of the star's demise more definitively. The scientists only estimate that the time until carbon exhaustion is perhaps under a couple of hundred years. Compared to different forecasts, the cosmic explosion won't happen for another 100,000 years. This is significantly earlier, but it should be mentioned right now that the study results from Japan are by no means free from criticism. For instance, astrophysicist Morgan McLeod criticizes that the data doesn't match the different investigations of the star. To be more exact, assuming we consider the multi-day cycle as the primary heartbeat, then Betelgeuse would become too large. So, at any rate, some question marks still loom over the new discoveries. Anyway, it's conceivable that Betelgeuse isn't just joined by question marks but also by something totally different. After all, new investigations suggest that it has an accomplice star, whose presence has escaped humanity for millennia. In this case too, it was the longer multi-day change that became the focal point of cosmic interest. A new reassessment by a group from the New York-based Flatiron Institute uncovered several amazing irregularities, such as the truth that the multi-day cycle in the star's light curve is likely to an unexpected rhythm in comparison to the subtle 400-day throbs. However, the researchers were unable to identify any accompanying peculiarities that would be related to causes such as rotation, magnetic field impacts, or convection flows. Thus, it resulted that, at the day's end, only one explanation remains that could conceivably make sense of the long, occasional variations, specifically, the presence of a smaller companion star. Alternately, the long, intermittent brilliance variations would subsequently reflect the orbits of the companion, and when it vanishes behind Betelgeuse as seen from our viewpoint, the cycle is at the low point of its brilliance. If, on the other hand, the companion is near Betelgeuse, the radiances of the two stars combine, and the brilliance reaches its maximum. Simultaneously, the companion star could also act as a natural dust shifter, impacting the distribution of the dust clouds and thus playing an extra role in Betelgeuse's brilliance changes. But in any event, assuming that this is actually the case, Why have we ignored the companion star for such a long time? Well, this is undoubtedly because of its low mass. According to the experts' computations, it tips the scales at just 1.7 solar masses, which makes it nearly 12 times lighter than its much larger partner. Besides, the companion star is believed to orbit Betelgeuse at a tiny distance, which corresponds to just 2.43 Betelgeuse radii. Accordingly, the companion is literally eclipsed by Betelgeuse, and its throb and brilliance changes do the rest to make identifying the heavenly friends significantly more difficult. Fortunately, however, confused doesn't mean impossible, and the specialists are now hoping to use large telescopes to reveal additional proof of the companion's presence, and maybe even to figure out what kind of star it is. And now, we're uncovering the presence of the accompanying companion star for our video. We'd be glad for you to press approval and subscribe now to never miss another video from us again. We'll see you soon.